Right, welcome back everyone to another video, and in this one I have my Chromebook and a very expensive USB type C to type A cable. Now this is probably the most expensive one I have with me. This one costs $14 but in the US, but if you want to ship it to halfway around the world, pay the customs. It's more like 40 US dollars at the end of the day. Um, and Yeah, so why do I need this? Why do I have my Chromebook out? Well, let's just talk about it. So this is what they call a SCSI cable, no? SCSI cable, spelled with a Q, SUZYQABLE. I don't know why that name's chosen at all. Maybe it's just an internal name they decided to make a product name, something weird like that. Anywho, here's the cable. It is a special cable. It is for a very special purpose. It will not charge your phone at all. It will also not communicate to your phone to your PC like a regular USB cable would do. So this is not a regular USB Type C to Type A cable. This is what you call a Chromebook debug cable or CCD cable, which is not Chromebook debug cable, which is closed case debugging, which basically means there are two ways to debug a Chromebook. If you've worked in that environment, you know this. For the people who don't know, the first one, and the oldest method, is to open up your Chromebook using all the screws like right there. Open that up. On the PCB you have a port called the server port, and then you need to have a specially built hardware called the server board. The purpose of the server board is specifically to debug a Chromebook. Chromebooks are manufactured by separate vendors, but they follow a common design guideline from Google, and everyone has that server debug port. Even this Chromebook has one, but it's in warranty. I don't want to open the screws unnecessarily, and sometimes these things are like factory fitted, and you open them the wrong way, and then they don't go back in properly. So I just wanted to preserve the purity of the actual hardware, um, while I completely mess up the software. So yeah, that's part one, why you don't use servo. That's the server board. The other thing is you can't just buy a server board. You have to get that manufactured specifically for you, or if you or if you know someone, or if you either know someone who has one, or if you directly contribute to the Chromium project in a major way, then Google will provide it to you. Unless you're doing that, it's very hard to debug one of these things. This is where the SuzyQable cable comes in. Not SCSI. SCSI is a completely different standard. I just realized that. Suzy cable with a Q. This is for sort of newer Chromebook, mostly from 2017 and onwards, have this capability. These Chromebooks, like this Asus CP101, has a C101P, always mess that up, has a CR50 chipset on board, which is basically not quite a Southbridge chipset, but like more of a management chipset or a BMC for all you server people. So all these Chromebook have Type C ports. This one has two, and one is dedicated. Not dedicated all the time, because this can do regular Type C and display port. But this particular USB Type C port near the hinge is where the CR50 chipset is connected. So if your Chromebook has a CR50 chipset, you can buy one of these cables and connect them. So what's so special about it? This cable actually has a teeny tiny microcontroller on board. So on the Type C end, you see these holes. This right leads to a metallic powered part down there. I'm not sure if it's visible, but if I twist it slightly, you can see it shine. And this particular area actually has a microcontroller. I hope I'm not wrong and it's not on this side, but makes sense to be on this side. And what that microcontroller does, splits the CR50 type C port into as a USB hub into two different ports. The first one gives you access to stuff like ADB if you're running Android or Android related applications, so that you can push your fastboot and ADB commands. The other bit accesses the CR50 chipset directly, which with a register onboard register configuration shows up as three debug ports. One is for your main application processor. In this case, it's the rock chip RK3399. We'll see everything in action, don't worry. The other one is the CR50 itself that has its own command line interface. And the third one is the AC, which has doesn't have a command line, but it gives you status about various power states and stuff like that. And EC is somewhat like a South Bridge, I want to say, but not quite. Um, and yeah, so that is that microcontroller is the reason why it's so special. Can you do without this cable? Kind of. I tried making my own and I failed because it wouldn't work. They do say that it's viable to use, like make your own solution like this one with a couple of resistors, and it should show up as the three debug. You do lose the ADB functionality, but it shows up as the three debug ports, the three TTY debug ports, and you can work your way through it. But this didn't work. The type C breakout boards are very hard to get, and that is one of the reasons I would prefer, and they're expensive as well. It's one of the reasons I would prefer to just go and buy one of these things if you are so inclined to debug a Chromebook. Um, so this can do various things, flash stuff. We'll go through the list in a bit. Um, so your Chromebook doesn't have to be on. That's kind of the scary part of this. If you just plug it in, the CR50 chipset is very much alive, even if your Chromebook is shut down, and it can do a bunch of things. Even like the power buttons and all of the other buttons are connected through the CR50 chipset, and it's aware of those buttons around it. So um, yeah, fear the CR50. It's kind of like the T2 chipset in a MacBook if you think it like that, but also not so much security focused. Um, right. So can anyone debug your Chromebook if they have this cable? Kind of yes. At least they will get the USB serial ports. Again, you need physical access, but they will get the USB serial ports. They can't mess up with your firmware unless your Chromebook's in debug mode and all of that crap. They can do a couple more things though. So yeah, let's plug it in. I do want to show you guys how this actually looks and behaves. I'll show the Chrome OS loading. I show Linux mainline loading using Arch Linux. I was hoping to get U-boot working, but I haven't quite nailed it. So that won't be shown today, but in a future video. But for now, the most expensive Type-C cable I have ever bought. Um, right, just a simple plug it in and go from there. So you see my console, my host system, it is running Fedora, and I'm going to plug this thing in. So take the Type C in and plug it on. It says that it's debug on here. So it goes only one way. It doesn't follow the Type C rule of going all in any direction, because it uses the multiple pins on the Type C and to create like a hub situation. Yeah, so they're kind of hacking the type C spec, not really following it. And the way I will get it to here is just simply plug. Now before I plug it in, I want to run dmessage here, so you guys can see what's happening, and I'll run it in continuous mode. So now I can just plug it in, and so it shows up as this Google device, SCSI cable or SUZY cable, Google link, serial number. This is what ADB uses and fastboot uses, and then you have your bunch of things you can use it for, and Funsoft, Flash Loader, Vivo Pay. I mean, it's just kind of the devices that it supports, plus a couple of generic things like Chromebooks will usually be just using the Google serial ID, and the other serial IDs are for other specific stuffs. Um, and here are your three debug, Type C debug stuff. So or TTY USB debug ports, serial ports. This one is for the CR50 chipset. The other one is for USB. This one is for your AP. So in this case, the RK3399, and this one is for the EC. And we'll see every one of them work in a second. Right. So I'll just open up a new tab. We'll just go simply through. Let me just say sudo. Surprisingly, it doesn't show anything. Probably if you're running Android, it will show up. But for now, you can do sudo picocom. This is just something I use. Some people use minicom. So we are going first into the CR50 firmware, or CR50 console, and I'll show you around. So here I can type CCD, and that gives me all the capabilities I have for close case debugging. So the state is open. This needs to be specifically open when the Chromebook's put into debug mode. You need to go into the shell and then open that up. Otherwise it remains closed. These are the functionalities that will always be working whether or not the CCD state is open. This can be changed to if open, and then you can close the CCD, and then it's more secure that way. So your application processor TX and RX and your ECTX is always working. You can write to the EC only if it's opened. Again, flash AP and flash EC is again only open. So people, if you have this closed state, which is a default state, people cannot write to your application processor or like override your firmware and the weird stuff like that. And then there are some more stuff that I haven't really looked into. Um, and then you have your flash read. This is probably for your AP and EC, and yeah, stuff like that. You can always close or not close, and then some trusted firmware stuff. So the TPM says it's in dev mode. This needs to be in dev mode, otherwise most of the CCD capabilities do not work again, as I said before. The weird stuff is, as I said, the Chromebooks shut down right now, but I can actually just click the power button and it recognizes the press. So it is listening to a lot of things even if your Chromebook is shut down. Again, the volume rockers don't do anything, so it's probably just the power button. Yeah, so let me open up the Chromebook, and we will halt at the like the developer mode page where I can switch between internal boot and the external boot, and then I'll show you guys what all is happening. So as soon as I open it up, the Chromebook gets powered on, and you can see all the logs from EC come up. I will just hold it there, Control H, and yeah, it started the AP. So I can now Control C back to the AP console. Now if I just boot the regular Chromebook, the regular Chrome OS, so with Control D. This will actually take a while for the console to come up because Chromebook doesn't have like the full boot log when it boots. It suppresses all the kernel logs and just gives you with the developer console and this little stuff here. So I can basically log in as root because again it's in dev mode, um, and I can do stuff like, and even like in Chromebook you can see the dev message isn't necessarily complete because it's at log level 7 I think, or 0. Yeah, log level 7, that means the least amount of logging done. So that's like even less than you'll see on a regular system. Only something that's necessary is logged. So right now we are in Chrome OS. Again, new name, you can see 4.4, and then I don't know if LSCP would be installed. It is, which is fine. um, so it says again Cortex A53, but it's dual A72 and 4 A53s. But that's okay. And let's reboot into Arch Linux. Again, this is like having a serial port on your Raspberry Pi or any other dev board. And we'll reboot. Now this time, once the boot option comes up, I will select booting from my SD card, and now on my SD card I have Arch Linux with mainline kernel installed. So you can see this is the entire boot log of that. So it's booting Linux on physical CPU, Linux version 5.4.0.1. So this is mainline, straight from the Arch Linux repositories, that boots fine on this board. And then here it's actually the default log level. We don't pass anything like that. And yeah, so we just go down there and all the PCI stuff is upstreamed and everything. So here we go into the Arch Linux ARM on a Chromebook. So we can do root and it's a bunch of things. So etc release gives us Arch Linux ARM and it's running on a Chromebook. So yeah, so that's the output from your AP. Now we can try and go for AC. I haven't really looked into what the output from AC really means, so I'm not really don't really know a lot of things about that. So again, volume up was pressed, volume down was pressed. That is reported by the EC. EC handles a lot of things like on different, depends on the device, I could see and stuff like that. So this is the power button pressed and my OS is going into shutdown mode, and you can see the shutdown mode has gone from state 0 all the way up from state 2. Seems like was the last one. Yeah, so easy controls literally everything. Mostly power related stuff, and then few of the slow speed peripherals. Even has acceleration and gyro and lid and chipset events and stuff like that. So it is handling a lot of stuff. So yeah, that was the some of the capabilities of the SuzyQable. If you are a Chrome OS fanatic and a Chromebook die-hard fan, you want to hack your Chromebook without really opening them up, then this is a very good investment, I'd say. Yeah, this particular, if you want to see the support, I'll link it down in the description, and all, or and also run like a screenshot of it here. Chrome OS's website has a really nice web page where they show whether CCD is supported or not, and if your Chromebook supports CCD, then this cable will work more or less. So again, thank you everyone for watching. I hope this was entertaining and informative in some way or other if you have a Chromebook. and are willing to spend at least for $14 depending on where you live to buy one of these cables. So yeah, thank you so much for watching, and I'll see you in the next one. Hit the bell and weird stuff like that. um, Bye.